In this video, we're going to take a look at the end behavior of the graph of a function using both graphs and tables. End behavior refers to what the graph of a function does as the x values approach infinity or negative infinity. The extreme left and right of the graph will either point up, down, or begin to flatten out. Mathematically, as the x values get closer to or approach positive or negative infinity, the f of x or y values either approach negative infinity or positive infinity or some number. This is what's referred to as end behavior. Here I've drawn a rough graph, and if we look at this graph, we'll notice that as x is getting smaller as it goes toward negative infinity, we notice that the y values are moving downward or getting smaller as well. So in this graph, we could actually write as x approaches negative infinity, and we'll use the little arrow for that, y also approaches negative infinity. So both are getting smaller and continue to do that to infinity or to negative infinity. What about the right side? So as x gets bigger, so as it just continues to get larger, it begins to approach positive infinity. What does y do in this case? Well, y is actually getting smaller as it was on the left side, so y is approaching negative infinity. So in this case, as x gets smaller, y gets smaller, but as x gets bigger, y also gets smaller. This is the end behavior of this particular graph. Here's another graph. Let's take a look at this one. So again, I'm going to look at as x is getting smaller or approaching negative infinity. So we'll write x approaches negative infinity. I want to know, what does y do? Well, just like in the other graph, as x is getting smaller, so is y. It's going down. Therefore, y is also approaching negative infinity. Same thing it was doing in the last graph. Now let's look at x as x continues to get larger toward positive infinity. So as x approaches positive infinity, what does y do? Well, this time y, instead of going down, is going up and is going to continue to go up. So y is approaching positive infinity this time. So unlike the last graph, when the x goes down, the y goes down, but as the x goes up, so does the y. So this is the end behavior of this particular graph. As we can see without even writing it out, if we flip the graph here or reflect it across the y-axis, now we can see a totally different end behavior, because as x goes to the left or gets smaller toward negative infinity, the y values head up toward positive infinity. And if the x values get larger, the y values get smaller, so they head toward negative infinity in this graph. So just the opposite of what we saw in the previous example. Got one more graph we want to look at. In this particular graph, we notice that as x gets smaller, so does y, as we've seen before. So x approaches negative infinity, and as it does, y approaches negative infinity as well. So that's not different from anything we've seen before. But look at the right side. As x gets bigger and bigger or heads toward infinity, it appears from this graph that y actually is approaching where x is, or where y rather, is equal to 0. So we say here that as x goes to infinity, y approaches 0. It actually is approaching a number or flattening out at this point. Now it's a little bit hard to tell from the graph exactly what it does. We don't know for sure that it's not approaching 0.5 or a really small fraction or something like that. So the best way to do that is what we're going to look at next, and that is, can we look at a table? So remember that if you have a graphing calculator, if you can graph a function in the graphing calculator, you're probably going to be able to look at a graph and tell when it approaches negative or positive infinity. But if it doesn't show easily in the graph what it's approaching, then you may want to look at a table of values to do that. Let's take a look at how you do that. So I have a function here that I would like to know what the end behavior is, and I put it in my calculator, making sure to put parentheses around the numerator and denominator, and I graphed it, and I realized that at both ends it was approaching some number, but I wasn't sure what that was. So using my calculator, I created a table using large values and very small values so that I could look at what it seemed to be getting closer and closer to. When I looked at the table in my calculator, these are the numbers I got when I put in 500, 1,000, 1,500, and 2,000 for x. So as x was getting larger and larger toward really big numbers, I noticed that the y numbers were getting closer and closer and closer to 1.5. So now I know, even though I could tell from my graph it was approaching a value, I know exactly what that value is. It turns out that as x approaches infinity, it's getting bigger and bigger, y is approaching 1.5. So once I determined from my graph that the values were approaching a number, I was able to look at my table and tell exactly what number that was. Let's find out what it is as x approaches negative infinity. So to do that, I'm going to create a table with really small negative numbers. So here's the table I got for that. So you can see from this table that as the numbers on x get smaller and smaller all the way down to negative 2,000, that this number is getting closer and closer and closer to 1.5, actually approaching it from below. So again, even though it's from a different direction, we can see that y is actually approaching 1.5 on the negative side as well. So as x approaches negative infinity, y is also approaching 1.5, just from below instead of above, as this one did. Now, if one of these is approaching infinity or negative infinity, you'll be able to tell very quickly with the table, because if it's approaching negative infinity, these numbers will just keep getting smaller on the y side. If it's approaching positive infinity, they'll just keep getting bigger, and it'll be obvious they're not approaching any particular number where the graph would flatten out. Graphing a function and looking at its graph in an appropriate window is an excellent way to determine end behavior, as long as the numbers on the graph are easy to see, like integers or small numbers, or they go to positive or negative infinity. For graphs that approach a number on the graph that is hard to determine exactly, however, you want to look at a table using extremely small or extremely large values for x to help determine the answer more precisely. Hey everyone, thanks for watching. Leave me a comment below to let me know if finding end behavior with a graph and table makes sense to you. If you found this video useful, I would appreciate it if you would click the thumbs up button to like the video, and if you haven't done so already, subscribe by pressing the subscribe button to support our channel so we can make more videos. Also, you can visit our website at mymatheducation.com for more information and problem-solving steps, as well as our social media links. You'll find the link along with other links of interest in the description below. Thanks again for your support.